Hey everyone, this is For Machine Learning Models All Devs Should Know. I'm Stan Dotloe, the Data Science Practice Lead here at Northwest Cadence.
And I'm Ryan Chynoweth, a data analytics consultant at Northwest Cadence.
You know, Ryan, every company now is a software company.
Yes, and whether or not you're based in the cloud or you're just
Traditional on-premises company that sells stuff, right?
yeah, you either create software for you or your employees or for your customers.
Yeah, absolutely. You can't get around in this world without some sort of mobile app or a website or some software.
Exactly, and so what we see oftentimes is companies like Netflix and Uber and Amazon. They um, they kind of set the stage. They're the things everyone wants to be when it comes to technology and when it comes to software.
Right, and they're disruptors, right? So we see Blockbuster was put out of business by Netflix. Cabs, they're getting a run for their money from Uber. The Skype, it's ubiquitous now. Amazon shutting down all those bookstores because it's so easy to order online.
Exactly, and we even see that in other industries. As you see here, J.P. Morgan, they know Silicon Valley is coming. These are traditional companies that are trying to revolutionize their industry with their software.
Well, that's good. That means there's a lot of opportunity out there, right?
Yeah, and I think one of the biggest things when it comes to software is utilizing your data so you can build intelligent applications.
Yeah, it really is changing the market, right? All of your apps are going to need data. All of your processes need deep insights. You're able to do things you couldn't have before, make decisions that you didn't have the data for prior to this.
Yeah, and now companies are collecting so much data, and there's so much open source, publicly available data that we can pull in and use to make predictions and use in our software. I think sometimes we kind of lose the idea of what can data do in software.
Yeah, it's really a transformative thing, right? Data really transforms the way you build software, what you build, the decisions you make, and machine learning. That is revolutionary. This is the time where it's becoming table stakes, right?
Yeah, and I think here we have this slide here, and I see text analytics here, and whether it's simply pulling down reviews on a product or reviews on customer service or IT ticketing systems, there's so much analysis you can do there to get better and to have this software integrated into your software.
Yeah, we see these all the time, right? Text analytics, just taking a chunk of text and deriving insights from it, is becoming really, really popular, along with some of these other things, churn analysis. So these things have always sort of been there, but the technology, the algorithms now are letting us do this in a new, smarter way.
Exactly. And should we look at examples
Yeah,
of how
absolutely.
specific companies have done this?
So the first one that I kind of like, Octo Lexia. So this is an interesting piece of software that identifies dyslexia by watching the way participants' eyes will move across a line of text. So it's able to really quickly identify if a person has dyslexia. And the earlier you catch that, the better it is, because you can start finding different coping mechanisms to help through that. And this is machine learning helping lives.
That's pretty cool. And we do see, with Heartland Bank, how they can take SQL Server 2016 and take Microsoft R Server and incorporate it into their line of business app, where they are trying to streamline new applicants so that they can get their loans faster, or they can know how much they can give this person. This particular example kind of gets me going because I love the Microsoft R Server and
Yeah.
SQL Server.
You're an R guy.
Yeah,
Yeah, this is very cool, sort of onboarding customers very quickly, making decisions about if they're a good credit risk or not, just on the fly, automatically.
and one more thing too, we see here it says data science scientists working with software developers. That's the goal. We see so many companies where they separate those two teams. There's software developers, and then there's the data scientists, and there's not very much communication. But with these products, Heartland Bank has been able to get those two teams to work really close, and it's worked out.
And your company may not have data scientists. We can look at sort of core logics, right? Core logics can look through your code base and determine how many bugs are there, about where it is. It can recognize anomalous behavior and point you to where you should be looking for that bug. That's super cool.
And so this is just a product that kind of plugs into your existing application. And so this could maybe even be something they could do at home with their own data, kind of monitoring their own application that way.
Yeah, so you don't even need data scientists now, especially because there's so many things right out of the box you can plug into your organization, to your software, to your processes to get smarter. So I think the question then is, what is machine learning?
Yeah, that is a good thing. We've kind of been talking about data science and machine learning. I think it was Bill Gates that first said that machine learning is computers that can see, hear, and understand. I think here we like to think of machine learning as the ability to solve really dynamic problems.
Oh, sure. So if you're a traditional developer, I see you got a quote up there, traditional developer, they solve a fixed problem with a fixed solution. But machine learning can solve dynamic problems dynamically.
Yes.
Right? That's very cool. So you use a model, an algorithm that gets smarter and smarter and smarter the more data it sees. And it can make decisions with better confidence quicker and quicker.
Yes, and it's an iteration process. So hopefully over time that model even gets better. It's better at predicting. It's better at...
So, now I think we're at a really great place where we're able to sort of, as Microsoft says, democratize data. But it hasn't always been that way, right?
No, and so I guess this is a good time to talk about Microsoft's role in this. In 1997, you see Hotmail launches, and what is junk mail, and how that is machine learning. If maybe it began, we got all of our mail, and you started saying, well, this is not interesting to me, so I'm going to start marking this as junk.
Yeah.
And pretty soon we were where we are now, and
so we take it for granted.
Never see junk mail.
That our spam filters have some intelligence in it, and it doesn't always work, but most of the time it does. And if you remember back then, before that, you just got inundated with junk you didn't need.
Yeah, and then 2008, Bing Maps. How do I get home?
That's a non-trivial problem, right? It's dynamic. Road conditions are always changing. There are infinite number of routes home.
I think one thing that's cool is you get in your car and you get a set route, but when you're on the route and it tells you, hey, updated route, you can save 10 minutes if you take this way. I think that, to me, that's where machine learning gets really interesting.
That's very cool. I loved the Connect. I did that. I built a project in that to sort of watch my exercise sessions and dynamically understand when I was doing different things. I loved that whole thing.
Yeah, and then Azure ML launches, and it brings machine learning to the everyday developer, Visio for data scientists, as sometimes we like to say.
Yeah, that has been great because it leverages some of the research that Microsoft has done. So you don't need data scientists. You're using what they've produced in your application. Right now you can do that. In 2016, I think that's where you want to get to.
The SQL Server and our server, it takes it to the next level.
And SQL Server 2017 has Python integration. I know you're an R guy.
That works
I'm
for
kind
you.
of a Python. Yeah,
that works for you. It's about time.
It's about time.
So these are kind of ways with Azure ML and SQL Server. It's kind of ways people can customly create machine learning solutions. But there's out of the box kind of analytic things.
You're talking about Cortana Intelligence Suite, right? All these APIs that have been just sort of developed by Microsoft that you can just consume right now.
It's kind of a plug-and-play type thing. And I think if we take a look, we have some examples of questions they answer.
Yeah. So your business probably has some questions. And you probably have some way of answering these, but they can be enhanced with Cortana Intelligence Suite. These very fraud detection, customers, when are they likely to leave? Things like that are solved out of the box because these are ubiquitous problems.
Yeah, and here we have some example solutions, whether it's customer acquisition or simple fraud detection. I think one thing we see here is the lifetime customer value. Is it better to try to keep the customers I have, or is it easier and better for my business to keep getting new ones?
Yeah, absolutely. Targeted marketing. We've been doing that very recently, and it's becoming a very popular thing.
Yeah.
Knowing who your customer is, what they'll be interested in, when you should approach them, what type of offer will entice them. These are things that machine learning, Cortana Intelligence Suite, can start to answer immediately.
Yeah, and so I think if people go look at the Microsoft Cognitive Services, these are the APIs we're talking about.
Oh, these are fun ones too, because you have things like Lewis. So when we talked about text analytics earlier, Lewis, Language Understanding Intelligence Service, trains on your domain. So it understands that if you're selling cars, when you say Jaguar, it means the car, not the animal.
Oh.
So it's very cool for text analytics. It's really targeted to your specific industry.
And I do think we've talked with a couple companies recently about the face APIs, being able to, take pictures as people walk through their doors and kind of know who they are or match it with a profile they have on a customer.
And I love that it can sort of determine their emotional state, right? It tells you how happy they are, how sad they are, how scared they are, and you can sort of make quick determinations off that. Like, do they like this ad you showed them based on their facial features?
That'd be so good. So where do we do some other machine learning?
I think Azure Machine Learning Studio is a really great place to start with machine learning. It has a lot of customized modules that you can pull in, like you said, just like Visio. Things that have already been created by data scientists with multiple PhDs, and we get to consume and leverage that right out of the box.
And it's pretty customizable with the R scripts and the Python scripts. You can really make it your own so it fits your particular needs if you need it to.
I think we're going to show that off a little bit later, right?
Oh, yes. We do have a demo coming up towards the end. But one other great thing about Azure Machine Learning is there's no software you have to install. With a lot of machine learning environments, there's a lot of installation and configuration, and
it's a lot of overhead. Yeah.
Azure ML, it's browser based, and
it's fully managed, right? It integrates with your other Azure solutions. You can create an API, call it. You can monetize it. You can deploy it very, very quickly, right? It comes with sample code that you can just copy and paste right into your application. And you can use R. You can use Python. You can use SQL transforms. You can use all their out-of-the-box capabilities, which is pretty robust, to start building models immediately.
And I think another cool thing is it's not just cloud data you have to work with. Yes, it's really easy to connect to other Azure resources, but you can connect to your on-premises data, and it's just as easy.
Yeah, you could upload a CSV if you wanted to.
So there is another resource people have, and I know
you want to get to R.
I know we talked about Python a little bit, but to me, R is one of the most powerful languages. I think. Sorry, I think.
Yeah, no, it's. I was going to say it's one of the most popular for data scientists.
Oh, yeah.
I know I'm a little bit behind the curve with Python. I like anacondas and panda and stuff like that. And you're an R guy, so I'll let you talk.
I think my favorite thing about R though is the community that surrounds it. There's over 7,000, maybe even more. It could be over 8,000 now. I'm not sure. But
the CRAN packages.
Open libraries that you can just kind of use and take those out of the box. You can write your own and publish them.
No, you are right. So because this is so popular, almost every situation has been faced and solved. So you can go out and pull different libraries in to solve your problem. Just customize it a little bit and boom.
Yeah, and with Microsoft kind of taking over, they've kind of really taken over R a little bit. Not taken over, but embraced it, I should say.
Sure.
And they've created Microsoft R Server and SQL Server with R services, and I guess now Python services as well.
But that's really good because it used to be that it was single-threaded. When you wrote in R, it was sort of slow, but now that's not the case, right?
Yeah, Microsoft R Server allows you to spin up kind of a cluster of machines and distribute your computation across them all for faster training time, bigger workloads, and just really give you this full analytical horsepower that you need. And it's supported on several different environments.
Okay, Ryan. I think we need to jump into the actual meat of this presentation.
What we're actually supposed to talk about.
What are the 4 machine learning models every dev should know?
All right, so the 4 we've really identified, they kind of fall in line with that Azure machine learning categories. Anomaly detection, clustering, classification, and regression.
Great. Let's talk a little bit about these. So when you're going to choose a model and you don't know, this is a great cheat sheet to help you sort of pick which model it is. We'll go into it a little bit more, but this is a nice way just to sort of understand which one to use. But the great thing about Azure Machine Learning Studio, that I like anyway, is it's built for experimentation. So if you don't know, you just experiment until you find which one works right for you.
And just so everyone knows too, this cheat sheet can be found on the Microsoft website, right? This is publicly available. Anyone can find it there. Should we get into the anomaly detection?
Yep, let's talk about anomaly detection.
All right.
So this is our first machine learning algorithm every dev should know.
1 of 4. So anomaly detection is this idea that you monitor your data, and when something doesn't seem right, you get alerted.
So when you have a pattern and something deviates from that pattern and it needs your attention, that's anomaly detection.
Yeah, and so some scenarios that we often see are fraud detection or IoT devices where you're monitoring a device, the vibrations or whatever it's doing, and if it deviates, then we know, hey, this piece of equipment might need to be serviced.
Yeah, absolutely. So you're getting all this telemetry data, and then boom, you get a metric that just jumps off the chart. You want to see why. Is something broken? Is there something weird going on with the environment? What's happening? And this just sort of is a way for you to find those anomalous activities within your pattern of data.
And the next one is clustering. Kind of how it's usually used for a lot of discovery and understanding what your data is doing and how it behaves.
Right. So clustering is an interesting one, right? This is a non-supervised learning algorithm. So that means you don't have to give it any training data. You throw the data at it and you say, I want you to divide up into 3, 4, however many clusters of things, and it will go through and it will find metrics to cluster your data into. So you might not know, right? You might just give it a bunch of things or people or something, and it'll tell you, here's group 1, here's group 2, here's group 3, and then you dig into the data and find out, why is this group related? Why is this group related? What's going on here? It can sometimes be super interesting results. It can other times be not so helpful, right?
Yeah. And I think one good application too is recommendations. So if we have a group of people, or we have a set of people, and we group them in, they get clustered into 4 different ones. We can kind of know, like, hey, maybe this group of people, they're all pretty similar. So we could recommend similar things to all those people. So that's one place where it's pretty helpful.
Absolutely.
More than just pattern recognition or discovery.
leading into that is like the classification. If we know up front that our data falls into bins, if we know that the people we're looking at falls into demographic buckets, maybe an age range or something, we say 18 to 25, 26 to 30, and then 30 plus, that's classification. We're classifying people or things into discrete buckets.
Yeah, classification's a really popular one, but they kind of have two different types of classification, right?
Right, so there's binary, there's that yes, no, true, false, 1, 0 type thing where you're bucketing your information into two separate classifications, or there's a multi-class classification, right? So where you take it into more than two, so 3, 4, 5, however many buckets you have. So let's say we wanted to classify animals. We would classify into each individual animal, right? That
could be a lot of animals.
That's a lot of animals, but that's a multi-class classification algorithm.
Yeah, and another really popular one, and I think this is our fourth out of four.
The last one, right?
The last type of algorithm is regression. This is when we want to know kind of a number.
A continuous variable.
Continuous variable, and we're often looking for a numeric outcome.
Right.
Something.
So this is something a lot of people do in Excel.
Yes.
Right? You produce, you have your data, and then you produce a line that sort of extends your data, that tries to best fit it. That's a R-squared value, right?
Mm-hmm.
And then you want to predict out where you're going to be at some time. Right? That's the classic sort of use for regression.
Exactly. And we do want to point out kind of the difference between regression and classification. While it may seem obvious to most, it's kind of important to know. And here we see like regression is that number, it's that continuous variable, while classification is categorical. You're trying to predict a label. And we see here we have some examples, estimating household consumption and whether or not a power station will or will not meet demand. That's a binary classification. Is it going to meet it? Is it not going to meet it?
Right. So if we're predicting power consumption or income, that's very much a continuous value, right? Whereas a answer, a yes or no, is a categorical value. Those are categories. So that's the difference, I think.
Exactly. And actually, I think it's time we show off some Azure Machine Learning Studio.
Let's do it.
Okay, so let's get right into a demo here.
So, Ryan, what demo are you going to show us?
So
I know you have a few.
So yes, in Azure, this is Azure Machine Learning Studio here, and we have some data sets. There's a ton of sample data sets if you want to play around in here. These are published by Microsoft, and you'll find a lot of these online.
Okay, so you don't have to go searching for data sets if you wanted to experiment.
No, and in particular, we're actually going to be using this German credit card data set found here. But I did some data cleaning before this, and so I actually uploaded my own version of it.
I think that's about 80% of our job, right, is cleaning data before we get to the fun prediction part.
It's often the most difficult part.
It is. Okay, so you took this, and what did you do to that data?
So if we take a quick look at our data here, a lot of it's going to be, it's already split out into categories. So while we see credit card amount or purpose here, like this A43, it doesn't really mean anything, but we have a data dictionary, so we can look up what that value actually means.
Okay. So there were a lot of values, and you went in, and what'd you do?
So first, what we're going to do here is we notice that we have a lot of numeric values.
Okay.
And after experimentation, I realized we kind of want to normalize those numeric values.
Okay.
It creates better results for us. So just kind of using a little search bar up here, that's kind of handy to have.
Okay, so we're going to normalize our data at first.
And the cool thing when we talk about Visio, it's a drag and drop interface. So we can just drag it right in there.
Okay, so Microsoft had created a module that normalizes the data, and you just pulled it in. You connected that line is what transfers one data set to a module to to produce another data set.
Exactly. And in this case, we're going to do all numeric ones except for the label. So in this case, the label is yes, they are credit risk, or no, they are not, and that's ones and twos. Okay, usually it's ones and zeros, but this data set had ones and twos.
Okay, so when you say label, you mean that's the value we're trying to predict. We want to predict, are they a risk or not?
Exactly.
And if they're a risk, they're a 2?
Yeah. Oh, no, if they are not a risk.
If they're not a risk, they're a 2. If they are a risk, that's a 1. So you are normalizing all the data except for the thing we're trying to predict.
Exactly.
Great.
And then next, with data science and machine learning, we often want to split our data.
Okay, so as I understand it, you want to split the data because you need a training data set and a validation data set. The thing there is you can overfit your data if you don't do that, right?
Exactly. And so when we don't split our data set, we often will overtrain our data. And when that happens, our model will be really good at predicting that data. It's not very flexible to new data, but when we split it, we kind of create this flexibility so if it sees something new, it can predict that.
Okay, so we want to give it some data to see how well it does with new data sets.
Exactly.
Okay, awesome.
So now it's actually time. So we kind of mentioned before, it's an experimentation playground. You can bring in as many models and predict, and in this case, we're actually going to bring in 2, so we can kind of compare and see them. So I'm going to be dragging in 2 of each module for a while, but we need a trained model so we can actually train our machine learning model.
Okay. So I see you split the data. It says 0.75. So 75% of the data is going to be used to train it.
Exactly.
Right?
And then we'll use the remaining to test it, to score the model.
Okay, so 25% is going to be used to see how well this model is trained.
Exactly.
Okay, great.
And these are the 4 categories we talked about before.
I see anomaly detection, classification, clustering, regression.
So in this case, we have a binary classification. So
right, because it's 2 values. It's 1 or a 2.
Exactly.
So binary. So 2 class.
And in this case, we're going to do a 2 class logistic regression.
Okay.
On one side.
So we're going to predict those values off a logistic regression, right? So it's going to take into account all those different fields to do a regression, and then it's going to produce a classification from that. Exactly. Interesting.
And I also pulled in a 2 class boosted decision tree.
Okay, by the way, that's one of the algorithms I use the most. It always has good results.
Yeah. Actually, on the popular data science website, Kaggle, we actually see that is one of the most successful machine learning models there. It wins a lot of competitions.
Yeah, very cool.
And then we're going to need to bring in a score model.
Okay, so you're taking the data, and I see you just drag in those models that Microsoft had developed. You don't need to know how they work, and you're just going to test them. So you train the model. It takes in a boosted decision tree and some data. It trains that boosted decision tree or that regression on that data, and then the scoring is going to apply that model to the data. It's going to score it.
Exactly. It's going to make predictions for us.
Okay.
And one thing we do need to do on trained models, we need to tell what we want to predict.
Okay, so it's going to train on this value. It's going to take all the other information and try to predict this one value.
Yes, and in this case, it's the label.
The label, okay, great. We got to do that for both. And so I saw when you're pulling in these modules, when you grab from one node to another, it lights up green or red.
Exactly. So we see that there? No. Okay, I gotta delete some of these in order to even see it.
Well,
so
maybe
right there.
Okay, it's green. So if it was red, you wouldn't be able to connect that up.
Exactly, just like this. So we see a green and
so
red.
try to connect it. No, it won't let you. Okay, great.
So it's pretty helpful.
Yeah.
And then finally, we want to compare these 2 models.
Okay.
And we're going to use an evaluate model for that.
Okay, so we're going to see how well our model performed compared to the other.
Yeah, and this one's pretty cool because it allows you to see both of them in the same view.
Ah, gotcha.
And so here we're all ready to go. And
So is this it? This is our model?
This is our model, and it's as simple as clicking run at the bottom.
Great. Now, a lot of times it seems as though there's more steps involved.
Exactly.
This I know you went through and you cleaned it already, but usually I know when you create models and I look at them, they look really complex because there's R scripts, there's Python scripts, there's SQL transforms, there's metadata edits. There's a lot of that data cleansing before you get here. You abstracted that away for us.
Exactly. In demos, it's just kind of hard to see all that and do all that.
So this can be as simple or as complex as you need it to be. You can start off super simple and then iterate over it, build on it, retrain it, and get valid results.
Exactly. And we see here as our model goes along, it looks like it finished, we do get check marks. So where we can see the progress as it goes.
Ah, very cool.
Okay.
So I want to see how well these models did. If we look into the score model, can we see the predictions?
Yeah, so we can see line by line with what the model predicted for each of our users.
Ah,
so
great.
It adds 2 columns at the end. It adds the scored labels, which is our prediction, and it adds the scored probability. So it gives you a probability along with it.
Okay, so if we go back there, we see that label column, and this is original column it trained off of, correct?
Exactly.
And then the scored label was its prediction, and then the probability is how confident it is of that prediction.
Yes.
Okay, so when we look at this, it looks like it's pretty close. Do you see any mismatches here?
I do not.
Ooh, there's 1,000 rows. I don't know if I could go through all those.
So one nice thing is you don't have to.
Okay.
So this evaluate model, if we open up and visualize this, it will kind of give you a summary of the results.
Very
with classification models, we like to see this ROC curve hug the vertical and the top horizontal line.
Okay, so the closer it is, the better.
Exactly.
Now, I've been in a situation where I've had that line exactly pull. I went to a customer site and it hugged it completely.
So with evaluating your model, you should always kind of keep in mind, right, that if it's too good, it might be too good to be true.
Yeah, that was the case. It was predicting all no's for something that had a very small amount of yeses. So it was 99.999% confident when it only said no.
It's kind of useless because you're
right.
Because if you're trying to sell something, and he says this person won't buy it, this person won't buy it. No one's ever going to buy it because you're not selling anyone anything.
Right. So you got to be a little bit careful when something looks too good to be true. It probably is.
Yeah, and so we also see we have some more statistics down here, like a true positive or true negative.
Right. So now let me see if I can figure this out. A true positive would be when you predict that the value is going to be positive. In this case, it looks like the positive label is a 2. So when you predict that it's a 2 and it actually is a 2, then that's a true positive.
Exactly.
And for a false positive, you predict that the value is true, but it's actually not. You got a false positive.
Yes.
Okay, so same applies to the true negative and the false negative.
Yes.
Okay, great. All right, so now we want to productionalize our model.
Yes, and to do so, it's just a couple clicks away. First, we're gonna rename it so it's more than just experiment created on 421. So we'll call it webcast demo.
Okay, great.
And now we need to pick which model we want.
Well, obviously the boosted decision tree, right?
Exactly. So we're gonna get rid of the logistic regression.
Okay, that was the red one that didn't perform as well.
Yeah,
right?
it did decent, but heck, we did a really good job with the...
Okay.
And so we need to rerun it to verify the changes.
So you made some changes, and because it already ran through all these modules, it's just checking. Make sure there's no changes to those modules.
And we see it's super fast.
Okay, great.
And we're going to set up a predictive web service. This would be like an API that people can hit in their application.
Let's do it.
And I think this is pretty quick, too. So we see that things are moving around, and it creates web service input and web service output. So this is where we would send data in, and then where we would get data out.
Ah, so it figures that sort of thing out for us.
Yes, and
very cool.
Now that it's set up, we just need to verify it once more.
Okay, so we're running it, make sure the changes it made didn't break anything.
Exactly. And this should be pretty quick too.
Okay, so once we have this, now how do I put it into my application?
Okay, so we're going to deploy it, and we're going to get redirected to another page here. And this is all the information you need to incorporate it.
Okay, so I see there's a request and response and batch execution. So we can either do this in batch or just one at a time with that API key it gives us.
Exactly. So you'll need this API key. That's how you access this. But if we go into this request and response, we actually can get some sample code that you mentioned earlier. And
very cool.
It's at the it gives you information about the request and the response.
Okay, so that's like a sample of what you might do.
Exactly. And all the way at the bottom,
I see these. It says the values it's expecting and the output values along with the data types.
Exactly.
That's pretty cool.
Really helpful documentation.
Yeah.
Coolest thing though is it gives you C#, Python, and R code.
Oh, so I can just copy and paste this right into my application and start using that API service.
Exactly. I think it's as simple pretty much as taking that API key and pasting it in right here.
Oh, that's so cool. So I could even monetize this. If I create a really good machine learning model, I can start charging people to call it.
Yes.
Oh, very cool. Very cool.
So that's Azure Machine Learning for you. I think in terms of next steps, we do have a call to action, I guess. We want you to identify areas where machine learning can be used in an existing application, or maybe you have a new application you want.
Yeah, and then once that's identified, start playing around. Develop a machine learning solution. Azure ML is a great place to start because you can start experimenting with drag and drop functions and really get going quickly.
And once you have that solution developed, put it in your application, test it out, see if your users or your employee, whoever is consuming that piece of software, that application, see if they like it.
And then make it just a little bit better with Microsoft Cognitive Services API, which you can now spin up in Azure.
Exactly. And if you guys have any questions, just give us a call. Client services at nwcadence.com, or us personally.
Yeah, absolutely. I would love to hear any ideas or questions you have. I think we spend more time than we should just sort of talking and brainstorming about this stuff. So we would love to do that with you.
Yeah, thank you.
Thanks.